Now that we understand how to divide and multiply fractions that involved mixed numbers and whole numbers, let's talk about a new term. Let's say we have the number 10. Well, we know that its reciprocal is going to be 1 over 10. We just flip it. What this means is that this reciprocal is the multiplicative inverse of 10 over 1. And we discovered that when we learned that 10 over 1 times 1 over 10 equals 1. Again, the reciprocal of a number, which is 1 over 10, is the multiplicative inverse. Here we have a multiplication sign. It's the multiplicative inverse of 10 over 1. That gives us the number 1. So the term we are now looking at is called an inverse. And the reason why I bring this up is because we are taking numbers like 3 over 4, and we are finding its inverse, which is 4 over 3. And when we multiply them together, we find that 4 over 3, the reciprocal, is the multiplicative inverse of 3 over 4. That gives us 1 because we can cancel all of these out. Now that we understand what an inverse is, let's move forward. Let's say we have a fraction like 11 over 16, and we want to divide it by a number like 10 over 14. Well, again, we need to remember to change this division symbol. So what we're going to do is we're going to rewrite out this first fraction here. We keep it as is. We're going to change that division symbol to a multiplication symbol. Since we changed that division symbol to a multiplication symbol, we now must take the inverse of 10 over 14 and rewrite it over here, which is 14 over 10. Well, now that we've written it out, we want to multiply, but we see that we can break some of these values down into nothing but prime factors to see if there's anything that we can cross cancel. So we come down here and rewrite 11 because that's a prime, but we know that 16 can be broken down into 4 times 4, which can also be broken down into 2 times 2 times 2 times 2. Then we're going to multiply. Well, this numerator can be broken down into 2 times 7, 2 primes, and then this denominator into 2 times 5. Now we see that we have some values here that we can cross cancel or cancel out. We have a 2 in this denominator and 2 in this numerator. We can cancel that. And it looks as though we can't really cancel anything else out, so let's multiply across and see what we get. Well, 11 times 7 is 77, and well, we have 2 times 2, which is 4 times 2, which is 8 times 2, which is 16, and 16 times 5 is 80, and so that's our final answer. Let's say we have a problem like 14 over 18, and we want to divide that by a mixed number, say 9 over 1/3. So what we're going to do is remember first that we need to convert this mixed number into an improper fraction. So let's start with that. So we bring the 14 over 18 over here. We're going to keep the division symbol because we're not taking any inverses yet. Then we're going to change this to an improper fraction. So 9 times 3 is 27. 27 plus 1 is 28. And we put that all over 3. Well, now what we want to do is change this to a multiplication problem. So we're going to come down here and we're going to write 14 over 18, but we want to change that division symbol to a multiplication symbol. When we do that, it's important to remember that we want to take the inverse of 28 over 3, which is 3 over 28. Well, we see here that we have two fractions that can be broken down into nothing but prime numbers. So let's start to do that. 14, we know, is 2 times 7, 2 prime numbers. 18, we know, is 2 times 9, but 9 is also 3 times 3. So we have those 3 prime numbers. Then we're going to come over here. The 3 is a prime, so we keep that. And then we know 28 can be divided by 2, which is 14, which can be divided by 2, which is 7. So now we have some fractions here with factors that can be cross-canceled. Whatever's in the denominator that's also in the numerator, we can cancel that out. So let's start with this one here. 2 times 7. We have a 2 times 7 over here. So let's cancel those out. Over here, we have a 3 in the denominator and a 3 in the numerator. So let's cancel those out. Now that it looks like we've pretty much canceled out as many numbers as we can, let's go ahead and multiply across. Here we have 1 and we have 1, so 1 times 1 is 1. And then in the denominator, we just multiply across. 2 times 3 is 6, and then 6 times 2 is 12. So our final answer is 1 over 12. Finally, let's say we have a number like 5 1/3, and we want to divide that by 10. Well, again, let's start to change everything to fractions and then move forward. So 3 times 5 is 15. 15 plus 1 is 16 all over 3. We're going to keep that division symbol because we're not finished. Then we're going to turn 10 into an improper fraction, which is 10 over 1. Now we want to change this into a multiplication problem. So let's bring the 16 over 3 over here. Let's turn that division symbol into a multiplication symbol. And then let's take the reciprocal, or the inverse, of 10 over 1, which is 1 over 10. Now we see that we have some fractions here that can be factored down into prime numbers only. Well, 16 we know is 4 times 4. But those can be broken down into primes. So we have 2 times 2 times 2 times 2, all over 3, which is a prime. And we're going to multiply that by 1, because that's a prime. And 10 can be broken down into 2 primes, 2 times 5. Now we can look at these two fractions and see if there's anything we can cross-cancel. Well, we have a 2 in this denominator and 2 in this numerator. Let's cancel those out. It looks like we have nothing else to cancel out, so let's multiply across. 2 times 2 is 4, times 2 is 8, times 1 is 8. And then 3 times 5 is 15. So our final answer is 8 over 15.